Welcome friends to another masterclass of the series on aviation. Today we'll be discussing about the basics of flying an aircraft. So inside the aircraft there are so many instruments that are there. So these instruments help the pilot in understanding its position, speed, location and many other things. So these instruments are very critical to understanding the flying of aircraft. Starting with the altimeter. So altimeter is one of the most vital instruments installed in the aircraft. It is because altimeter gives the aircraft's height above the mean sea level. These are the key terms that the aircraft's height above the mean sea level is given by the altimeter. So in aviation everything is measured with respect to mean sea level. Why? Because as we change the location, as we travel from one place to another place, so due to the pressure difference many things will change. So that is why all the heights are taken in MSL only. This also we have to remember. So what does altimeter actually do? So altimeter actually uses the pressure as its source of operation. This is the important thing to remember. So how does it work? So altimeter is basically a barometer. This is a key term to remember. So that measures the pressure of the atmosphere at the level where the altimeter is located. So let's say that if the aircraft is here, then the barometer present in the altimeter will measure the pressure of the atmosphere surrounding the aircraft, and then using that it knows the height. This altitude will be displayed in front of the pilot in the altimeter. So this height is always given in the feet by the altimeter. So this is also a key term to remember. Some other points which I would like to discuss are, that is, air is denser at sea level, so as the altitude increases, atmosphere pressure decreases. Then, since this pressure is changes, so this pressure, the difference in the pressure at various level, it causes the altimeter to indicate changes in altitude. So, what does the altimeter consist of? So, altimeter is, it consists of a sealed aneroid wafers. This is the key term, that aneroid wafers are there inside the altimeter, which is the main component of the altimeter. So what happens is, these are the aneroid wafers if we see in this diagram, which are circular in shape. So these wafers are free to expand and contract with the changes to the static pressure. So depending on the atmospheric pressure, these wafers will expand or compresses. So because of these changes in the pressure, the altimeter will be able to know its altitude. As you know, all the electronic instruments have to be calibrated before they are using. Calibration is a process where the correctness of the equipment is known. So one of the calibration unit that is used for the altimeter is the hectopascals. So this is the key term to remember. And also in some of the other places it uses the mercury are used. So the standard atmospheric pressure is measured in 101325 Pascal, or it is also equivalent to 29.92 inches of mercury. This is also a key term to remember. So the second important flight instrument is the vertical speed indicator, which is also known as a VSI, and it is sometimes also known as a vertical velocity indicator. So what this instrument does, it gives the whether the aircraft is climbing or the aircraft is descending or the aircraft is flying at a fixed level. So these indications are given by this instrument VSI. So how does this work? This instrument works on the principle of a differential pressure. That means it uses the pressure to, to know the speed, but then it uses a differential pressure. It compares the atmospheric pressure with its internal pressure, which is calibrated. So what this instrument consists of is, it consists of a diaphragm that is connected, and there is a calibrated leak that is there. So what happens is, the internal pressure is calibrated and is set to a certain fixed pressure, and the atmospheric pressure which is outside the aircraft will be sensed by this diaphragm, and then the pressure known by this is compared with the calibrated pressure. So the difference of this is known. So this difference will give an indication as to whether the aircraft is climbing, descending, or it is at a constant level. So that is what it says. When the aircraft is on the ground or the flight is level, the pressure inside the diaphragm and the instrument case are equal, and the pointer is at a zero indication. Similarly, when the aircraft climbs or descends, the pressure inside the diaphragm changes immediately because of the outside pressure. So this causes a pressure differential that is indicated on the instrument needle. So that is how this equipment works. Next is there is another important instrument which is a airspeed indicator. So what this instrument does is the airspeed indicator shows the speed relative to the surrounding air. So the speed of the aircraft is known using this. So what technology it uses or what science it uses is it also uses a differential pressure. The concept behind this instrument is also differential pressure. So what it does, it measures and it promptly indicates the difference between pilot and the static pressure. So similar to the vertical speed indicator, this also works on a differential pressure wherein a diaphragm is there and using an internally calibrated pressure and comparing with this, it will come to know the speed of the aircraft. So that is how it does. So when the pressure of the calibrated as well as the diaphragm are equal, then the aircraft can be considered as to be a zero speed or it is a steady one. The key point to remember is the difference in the pressure is registered by the airspeed pointer. So it shows this is the airspeed pointer which is displayed to the pilot. So using this, the pilot will come to know about the airspeed. So this is generally shown either in miles per hour or nautical miles, or sometimes it shows both. Some key abbreviations which I want to share with you are IAS is the indicated airspeed, CAS is the calibrated airspeed, and TAS is the true airspeed.